Redox reactions. The redox reactions, as far as the classical ideas of redox reactions are considered, let us firstly consider the different ideas of the redox reactions. Again, we have to study the oxidizing agent, that is oxidant, reducing agent, that is a reductant. Basically, the redox reaction, it is a abbreviation used for the terms oxidation and reduction. So redox is a combination of these two words, oxidation and reduction. Oxidation is a reaction. Similarly, reduction is also a reaction. And there is a particular reaction. And as far as oxidation and reduction, the reactions are considered, the different views are there behind the oxidation and reduction reaction. There is a classical idea of oxidation and reduction reaction. Similarly, oxidation and reduction reaction can be explained on the basis of electron transfer. So, the oxidation and reduction reaction can be explained with different views. We know why does the cut apple turns brown when it is exposed to air. Similarly, old car bumpers, they change color. Similarly, the new batteries become useless after some days. Why does such things take place? The reason behind is due to the oxidation and reduction reactions they take place. Similarly, we know the combustion reaction, that is a burning. Combustion reaction म्हणजे काय? Burning, ज्वलन. कोणत्याही पदार्थाचं ज्वलन होणं, ह्याला म्हणायचं combustion reaction. So we know a combustion reaction, and this is an example of oxidation and reduction reaction. एखाद्या पदार्थाचं ज्वलन होणं म्हणजेच काय, तर ती ऑक्सिडेशन रिडक्शन रिएक्शन असते. म्हणजे ज्वलन म्हणजेच ऑक्सिडेशन अँड रिडक्शन. दॅट इज कंबशन रिएक्शन is an example of oxidation and reduction reaction. So these are some examples we have explained. That is, the cut apple, when it is exposed to air, turns brown. Or old car bumpers, they change their colors. Similarly, new batteries become useless after some days. These are some examples of oxidation and reduction reactions. These facts takes place due to the oxidation and reduction reactions. Now, the classical ideas of oxidation and reduction reactions, that is the redox reactions. Let us explain these classical ideas with the help of some examples. Oxidation refers to combination of an element or a substance with oxygen, according to these classical ideas of redox reactions. Oxidation means combination with oxygen. That is, whenever an element or a substance combines with oxygen, the reaction is called oxidation reaction. In a very simple language, जेव्हा कोणत्याही पदार्थाचा ऑक्सिजन बरोबर संयोग होऊन त्याचं ऑक्साईड तयार होतं, अशा रिएक्शनला ऑक्सिडेशन रिएक्शन असं म्हणायचं. This can be explained with the help of some examples. For example, carbon in a solid state, when reacts with oxygen, gives carbon dioxide in a gaseous state. So carbon combines with oxygen, producing carbon dioxide. Similarly, magnesium, when combines with oxygen, gives magnesium oxide. That means when magnesium ribbon, it is burned in air, it produces magnesium oxide. In previous standards, you have done this experiment. When magnesium ribbon is burned in air, the oxygen present in an air reacts with magnesium, producing magnesium oxide. So this is a reaction between magnesium and oxygen, producing magnesium oxide. So these two examples explain that carbon combines with oxygen, producing carbon dioxide. Magnesium combines with oxygen, producing magnesium oxide. And therefore, in this reaction, carbon and magnesium are oxidized to carbon dioxide and magnesium oxide respectively. Now, this is one idea, classical idea of oxidation and reduction reactions. Now, let us consider the another example to explain the redox reactions. Now, twice of Fe2O3 ferric oxide plus thrice of carbon gives 4Fe solid plus thrice of CO2 gas. So in this reaction, Fe2O3 combines with carbon and free iron is produced in a solid state and carbon dioxide is formed. Now in this reaction, removal of oxygen from Fe2O3 takes place. And hence Fe2O3 is reduced. So in this reaction, oxygen is removed. या रिएक्शन मध्ये ऑक्सिजन रिमूव्ह केलेला आहे. Fe2O3 मधून ऑक्सिजन रिमूव्ह झाला आणि Fe तयार झाला. आता या दोन एक्झाम्पल वरून आपल्या असं लक्षात येतं की वर एक्झाम्पल्स दिली कार्बन आणि मॅग्नेशियमचं कॉम्बिनेशन विथ ऑक्सिजन गिव्स कार्बन डायऑक्साइड अँड मॅग्नेशियम ऑक्साइड. दिस इज अ ऑक्सिडेशन रिएक्शन. आणि या रिएक्शन मध्ये काय होते, असलेला ऑक्सिजन रिमूव्ह झाला, Fe2O3 मधून O3 गेला, ऑक्सिजन गेला आणि Fe तयार झाला. म्हणजे काय झालं, ऑक्सिजन इज रिमूव्ह. आणि याला म्हणायचं इन दिस रिएक्शन इज called the reduction reaction. That is, Fe2O3 is reduced to Fe. So combination with oxygen is oxidation and removal of oxygen is a reduction. So these are two opposite things. This is first classical concept behind the oxidation and reduction reactions. Now, आता याच्या पुढची एक रिएक्शन विचारात घेऊया की ऑक्सिडेशन आणि रिडक्शन हे समजून घेण्यासाठी वेगवेगळे कन्सेप्ट विचारात घेतले जातात. त्यामध्ये आता तिसरी गोष्ट पाहतात, तिसरी बाब काय? नाउ कन्सिडर द रिएक्शन. आता ही रिएक्शन विचारात घ्या. मॅग्नेशियम सॉलिड प्लस फ्लोरीन गॅस gives magnesium fluoride in a solid state. Now, fluorine is electronegative. We know this. It is highly electronegative. Similarly, Hg2Cl2. ही रिएक्शन काय होते? Hg2Cl2 च HgCl2 फॉर्म होते आणि फ्री Hg मिळतोय, मर्क्युरी. तर या ज्या दोन रिएक्शन्स आहेत त्यामध्ये पहिली जी रिएक्शन आहे मॅग्नेशियम विथ फ्लोरीन, दॅट इज कॉम्बिनेशन ऑफ इलेक्ट्रोनेगेटिव्ह एलिमेंट, इज ऑक्सिडेशन or removal of electropositive element is oxidation. Fluorine is a highly electronegative element. So magnesium combines with fluorine, forming magnesium fluoride. And that is why it is an oxidation reaction. Electronegative element, now electropositive element. Generally metals, they are electropositive in nature. So Hg2Cl2 is converted into HgCl2. So metal, that is Hg, it is removed from Hg2Cl2. That means removal of electropositive element is also called as an oxidation. So, आतापर्यंत आपण ऑक्सिडेशन आणि रिडक्शन या कन्सेप्टच्या क्लासिकल आयडियाचा अभ्यास केला. त्यामध्ये पहिली गोष्ट आपल्या अशी लक्षात आली की ऍडिशन ऑफ ऑक्सिजन, इट इज कॉल्ड ऑक्सिडेशन. आणि दुसरी आयडिया अशी लक्षात आली की ऍडिशन ऑफ इलेक्ट्रोनेगेटिव्ह एलिमेंट इज एन ऑक्सिडेशन. आता ऑक्सिडेशनच्या बरोबर विरुद्ध रिडक्शन असते. म्हणजेच काय? रिडक्शन इज रिमूव्हल ऑफ ऑक्सिजन अँड एडिशन ऑफ इलेक्ट्रोपॉझिटिव्ह एलिमेंट इज अ रिडक्शन. सो अगेन पुन्हा एकदा रिपीट करतो थोडक्यामध्ये. ऍडिशन ऑफ ऑक्सिजन and addition of electronegative element, it is called oxidation reaction. And removal of oxygen and addition of electropositive element is a reduction. बरोबर ऑक्सिडेशनच्या विरुद्ध रिडक्शन reaction. This is a classical idea of oxidation and reduction. Now, let us consider the oxidizing agent. त्यालाच ऑक्सिडंट असं म्हणतात. and reducing agent म्हणजेच काय? तर रिडक्टंट. So oxidizing agent and reducing agent. What is an oxidizing agent and reducing agent? That we have to study now. Now, a substance which itself undergo reduction and oxidizes the another species is called oxidizing agent. जो पदार्थ दुसऱ्या पदार्थाचं ऑक्सिडेशन करतो अशा पदार्थाला ऑक्सिडायझिंग एजंट असं म्हणायचं किंवा ऑक्सिडंट असं म्हणायचं. फॉर एक्झाम्पल, लेट अस कन्सिडर द रिएक्शन Mg solid plus F2 gas gives MgF2 solid. आता या रिएक्शन मध्ये काय होते तर मॅग्नेशियम अंडरगोज ऑक्सिडेशन and fluorine undergoes reduction, and therefore the magnesium is a reducing agent and fluorine is oxidizing agent. Because magnesium, it carries out the reduction and fluorine, it carries out the oxidation. Hence magnesium is a reducing agent and fluorine is oxidizing agent. Similarly, consider the following reaction. Mercuric oxide, HgO solid, it produces Hg and oxygen, O2. In this reaction, HgO reduces to Hg and oxygen. So reduction of Hg takes place. So HgO is converted into Hg and oxygen. So with the help of these examples, we can define as reducing agent. So it can be defined as a substance which itself undergoes oxidation and reduces another species is called reducing agent. तर जो पदार्थ दुसऱ्या पदार्थाचं रिडक्शन घडवून आणतो अशा पदार्थाला रिड्युसिंग एजंट असं म्हणायचं, म्हणजेच रिडक्टंट असं म्हणायचं. Now, oxidizing agent and reducing agent, they can be explained with the help of this diagram. Here X and Y, these are two species, and from X to Y, the electron, it is lost. Here loss of electron takes place. So X is converted into Y, and during this conversion, electron is lost. So X loses electrons, and this electron is taken by Y. That means X itself undergo oxidation, and it carries out the reduction of Y, and therefore X is a reducing agent, and as X is a reducing agent, Y is oxidizing agent, because Y gains electrons. That means X is oxidized by Y and Y is reduced by X. So by losing electron, a species become more positive, and by gaining electrons, these species become more negative. So in short, म्हणजेच काय, रिड्युसिंग एजंट म्हणजे काय, जो सबस्टन्स इलेक्ट्रॉन लूज करतो अशाला रिड्युसिंग एजंट म्हणायचं. आणि ऑक्सिडायझिंग एजंट म्हणजे काय, की जो सबस्टन्स इलेक्ट्रॉन ऍक्सेप्ट करतो त्याला ऑक्सिडायझिंग एजंट. Now let us study the competitive electron transfer reactions. Here zinc plus copper nitrate gives zinc 2 plus Cu. In this reaction, zinc has lost electrons to form Zn2 plus, and therefore zinc is oxidized because it has lost electron. या रिएक्शन मध्ये झिंकने इलेक्ट्रॉन लूज केले, म्हणून झिंकचं काय झालं, ऑक्सिडेशन. Now consider the another reaction. Cu plus twice of Ag plus gives Cu2 plus twice of Ag. In this reaction, copper is oxidized to Cu2 plus and Ag plus is reduced to Ag. म्हणजे काय, तर कॉपर Cu त्याच्यावर चार्ज 0 आहे, परंतु त्याचं Cu2 प्लस फॉर्म होतोय, म्हणजे त्याच्यावर 2 अधिक चार्ज आला. कशामुळे आला, तर 2 इलेक्ट्रॉन लूज झाल्यामुळे. म्हणजेच कॉपरनं 2 इलेक्ट्रॉन लूज केले. दॅट मीन्स कॉपर इज ऑक्सिडाइज्ड. It is oxidized to Cu2 plus. 2 electrons are lost. At the same time, Ag plus is converted into Ag. That means Ag plus has accepted the electrons to form Ag. That means Ag plus is reduced. Now consider the another reaction, third reaction. Cobalt solid plus nickel 2 plus aqueous. It produces cobalt 2 plus aqueous plus nickel solid. At equilibrium state, the chemical test shows both Ni2 plus aqueous and CO2 plus aqueous. They are present at moderate concentrations in the solution. That means here we are discussing the competitive electron transfer reaction. First reaction मध्ये काय झाले, zinc with copper nitrate. Zinc has lost electron, hence it is oxidized. And copper has gained electron, hence it is reduced. आता second reaction मध्ये copper has lost electron. पहिल्या एक्झाम्पल मध्ये copper has gained electron. परंतु दुसऱ्या एक्झाम्पल मध्ये कॉपरनं इलेक्ट्रॉन लूज केलेले आहे. And that's why copper is oxidized to Cu2 plus. And in this example, third example, copper solid plus Ni2 plus aqueous gives cobalt solid plus Ni2 plus aqueous gives cobalt 2 plus aqueous plus Ni nickel solid. And in this example, at equilibrium state, the chemical tests show that presence of both Ni2 plus as well as CO2 plus in an aqueous solution at the moderate concentrations. Now let us study the electron transfer concept to explain the redox reaction. That is, redox reaction in terms of electron transfer. And let us this concept explain with the help of different examples. The first example, magnesium in a solid state with oxygen produces magnesium oxide. That is, magnesium combines with oxygen to form magnesium oxide. The magnesium हा मेटल आहे, oxygen हा नॉन मेटल आहे. Generally, the metals have tendency to lose the electrons. And non-metals have tendency to accept electrons because metals are more electropositive. Non-metals are electronegative. In this reaction, loss of electron and gain of electron takes place. So magnesium, when reacts with oxygen, producing magnesium oxide, this reaction represents the loss of electron and gain of electron. That is, 2 electrons are lost by magnesium and they are gained by oxygen. Similarly, Mg plus F2 fluorine gas gives magnesium fluoride. So in this reaction, 2 electrons from magnesium are transferred to F2 fluorine. Now consider the third example, that is Fe solid. When combines with copper, it forms the compound. And therefore, thus, the oxidizing agent is a substance which itself undergoes reduction and causes oxidation of another species. So, oxidation or the oxidizing agent, it itself undergoes reduction. Therefore, the oxidizing agent is electron acceptor. And opposite is the case in case of reducing agent. That is, reducing agent is a substance which itself undergoes oxidation and causes reduction of another species. And thus, the reducing agent or the reductant is electron donor. So in short, the oxidizing agent is electron acceptor, while the reducing agent is electron donor. So this is a difference, or we can define the oxidizing agent and the reducing agent. So in brief, oxidizing agent is electron acceptor and reducing agent is electron donor. Okay? So these are the classical ideas of oxidation and reduction we have explained. Okay.